Hi, welcome to the Lab 2 tutorial. In this video, I'm going to show you how to import files into your workspace and compute z-scores and probabilities using the R programming language. So the first thing I'm going to want you to do is to download a CSV file that's going to have the data uh, and download this from Canvas. And so this CSV file is going to look something like this. It'll have two columns where each column is a variable. The first column is a student variable that contains all the particular students. And the second column is a scores variable that contains their respective scores on some test. Now notice that line 1 doesn't actually contain a student with their score, but line 1 is actually the variable names. So this is something that you just kind of have to watch out for, because sometimes when you're importing files into R, sometimes those files, the data actually starts on line 1, and you have to let R know that so that it can properly take in the information. But you're not going to need to know that for our particular assignment. So let's go ahead and go to R and import this file. So the first thing that you need to know about RStudio is that when you import, in order to be able to import files, R has to be connected to the directory where those files are found. So if you look down here on the command line, I'm going to use the getWD function, which returns a string containing uh, the particular location where our computer memory system is currently located. So it's these are like folders within the folders. So the Hector Ivan Lopez Villegas folder is inside of the users folder, which is inside some more base root folder. So um, the CSV file that I'm going to be working with that I just showed you, the lab2 scores demo.csv file, is located in a different folder, so we have to navigate our RStudio environment to that folder. So I'm going to go move up here to the RStudio tabs and click on Session. Then I'm going to click on Set Working Directory, then Choose Directory. Now I'm going to go up here and click on, actually I'm going to show you exactly where it is. So I'm going to click on desktop because I placed it in the folder called lab2. And as you can see here, it's not, they're sort of blurred out, but you can see that we have the lab2 demo, lab2 scores demo.csv file within this directory. So I'm going to hit open, and as you can see, the function, the command setwd was just automatically run when I clicked that way. And you could actually use the setwd function as well to set your working directory, but I think it's easier to just click on the session tab. So let's get WD again, get our working directory. Now you can see that we are in lab 2, and if I use the what is it? I believe it's files. Let's I believe the command is list.files. Oh, there we go. Yeah, so list.file shows you all the files that are in this directory. So we have this lab2 demo, which I used for the PSPP demo that I made. And we have this lab2 scores demo.csv, which is a file that we're going to read into our work environment right now. So let me clear all this. Control L. So in order to read in those files, there's a number of functions that we can use. The one we're going to use now is the read.csv function. So because we know that the file that we're working with is a CSV file, we could use this function specifically, which sort of speeds up the process of reading in that file. Since this file is really small, it doesn't really matter, but if the file was very long and we knew it was a CSV file, using this function would be best. So let's read this in there. The argument that it takes is the name of the file within parentheses, and also remember to put the extension, the CSV part of it. So let's read this file into our workspace, and as you can see here, we've created a data frame inside of a variable called myData with 6 observations of 2 variables. So let's see what this looks like. So it looks like our CSV file with 2 columns and the particular observations. So let's go ahead and make a histogram of this, of the scores variable in particular, just so that we can see what it looks like using the hist function. And again, we access that particular variable by attaching it with a $sign to the name of the data frame variable. And we're going to set it to look yellow using the col value. Let's run this. And here is our histogram. So if you're on Windows, you can use a snippet tool to take a picture of this, which you can later paste onto your Word document for your report. If you're on Mac like I am, you can hit Shift, Command, and 4. It brings up this little target, and then you can take a picture of this. It saves that image onto your desktop. Now we're going to compute the z-scores. There's 2 ways of doing this. I'll show you both ways. So the first way is to sort of imitate the formula of a z-score, right? The z-transformation formula, which is take the raw score and subtract from it the mean of that particular data set, and then divide that whole thing over the standard deviation of that data set. So as you can see here on line 25, that's exactly what I did. Within these first parentheses, I have my data, and I'm accessing the scores variable, and I'm subtracting from it, and then I'm using the mean function here and putting the my data scores variable inside of it. So it's going to find the mean of this variable, and it's going to subtract that mean from all of those scores. And then I'm going to put all that over the standard deviation. So I use the SD function and put the variable inside of it as well. So let's run this line of code. Okay, so it's in there. Now, oops. So if you notice here, I use the assignment operator to put it into my data, and this variable here, z-scores, didn't exist before, so it was created in this line, and I assigned it also by I use the syntax of putting a $sign after the data frame variable name. So let's see what this data frame looks like now. As you can see here, there's a 3rd column added, which is a z-scores column, and which is different from the previous data frame. So now that I showed you how to do it that way, let me remove this column, and then I'll show you how to do it the other way. So this code here, that's all this does, and that's what this writing here explains. So this isn't part of the lab. I just kind of wanted to use the same data frame. So let me remove that column with this line 29. That code does that. I'll remove that, and let me show you what it looks like once again. So we're back at 2 columns. So this is the other way of adding z-scores variable onto that data frame. So we can use the scale function, which takes the scores and converts them into z-scores, but the problem is that it returns a matrix and not a vector, which is what we actually need. So let me show you what that looks like. So let me run line 33. And if you look over here, you can see that I was put into my work environment. And let me show you what that looks like. So as you can see here, it's a matrix. A vector has 1 dimension, a matrix has 2. And but it's the same z-scores that we saw up here. So they're the same thing, but it has all this other information which is kind of ugly. So what we can do is we can take this matrix and convert it and coerce it into a vector with the as.numeric function. So let me do that now here on line 37. So run this, and now you can see example here. It changed its the way it looks. So let me show you. So now it's a vector. You see, it's just one list, right? And here this was a matrix. So that is actually what we need. So the best thing to actually do is to to nest both of these functions within each other to create a composite function. That way we can fit everything into one line. So this is it here on line 43. So as you can see, I've passed inside of the numeric function, I've passed to it the scaled function, which has inside of it that variable for the scores. So the scale variable with the scores is going to return that matrix, and which is the output, but that output gets immediately fed into the as numeric function, which then converts it to a vector, and then we're going to pass that into our our data matrix, creating once again this z-scores variable. But as you can see down here, let me clear this. If I just print this data frame, you can see that it's just the two variables right now. And this scale and numeric things, I just put them in an example, so it's not in the data frame. So let's run it this way. Okay, so with the composite functions way, and create that z-scores variable. Okay, so let's show you how it's created a z-scores variable once again. Okay, so now lastly, we need to create the probabilities that are found to the left of that particular z-score under the curve. So we're going to use a p-norm function. So the first argument to the p-norm function is a z-score, or a vector of z-scores, which we have here, and the second argument is where the distribution is centered, which is 0, and its standard deviation, which is 1, is the third argument. So let's run this line of code, and run it, and let's see what the data frame looks like. Let's run this, and now we have our data frame that has the scores, the z-scores, and the respective probabilities. And this is true. These are correct. They're not necessarily rounded to what we might find in the table, but they're close. For instance, if we look at any one of these z-scores, we can see that, for instance, let's look at negative 0.86. We'll see that the probability associated to the left of that will be 19%. So negative 0.86. Let's over here, negative 0.8. And so the sixth column is over here. It's 2 away from this middle line. So negative 0.86, right? So we're looking at this number here, which is 0.1949. And we're getting 0.1927. So they're not exactly the same, but they're close. So that's pretty much it. That's all you need to know for the lab. In conclusion, as I put down here in this file, you really only needed 4 lines of code to run this whole lab. It was a read.csv function to read in the information, the hist function to make the histogram, the composite function made up of scale and as numeric functions with the scores variable passed into it, and the p-norm function to create the probabilities. So I am going to put this file also on Canvas so that you can look at it and play around with it. When you download it, your computer might change it into a text file. So if you look down here in this corner where it says RScript, it'll be a file that looks something like this. So if you want to work with it, when you import it into R, make sure that you change its extension once again to R script, and then you can work with it. Okay, so that's pretty much it. I'll see you in the next video.